Hello students, this class we will study very important transducer, very widely used very important transducer in industrial applications. It is a linear variable differential transformer, short called as Lvdt, linear variable differential transformer. So by the completion of this lesson, you will be able to know the construction, the working principle of Lvdt, advantages of Lvdt, disadvantages and applications of Lvdt. So in the previous class we have studied about the working principle and construction of different types of transducers like straight gauge, potentiometric transducer, inductive transducer, capacitive transducers, their applications. Coming to the linear variable differential transformer (LVT), it is a passive type of passive electromechanical type of electromechanical displacement transducer. It is a passive electromechanical displacement transducer used to measure the force that may be a weight, pressure. This force may be a weight or pressure or acceleration. This depends on force. Force in turn depends on distance and depends on the displacement. So by measuring the displacement, we can find the force and thereby we can measure the pressure, acceleration, weight, etc. The output is measured in terms of displacement of the core. So LVDT, linear variable differential transformer, also known as differential transformer, is a passive inductive transducer. It is a passive inductive transducer and is most widely used inductive transducer to measure the force, weight, pressure and acceleration, which depends on the force again in terms of amount and direction of displacement of the ferromagnetic core of a transformer. So the displacement of the ferromagnetic core of the transformer is measured. Thereby we can find the force or weight or acceleration or pressure. Lvdt transducer is primarily used to measure the linear displacement. It comprises a transformer with construction. So it consists of a transformer with one primary and two secondary windings with a mobile core between them. It consists of a transformer with one primary and two secondary windings, coils with a mobile core between them, like this figure here. One primary and two secondary windings is secondary and second winding. This is a primary winding. Two secondary windings and a mobile core. Consists of one transformer with one the primary winding and two secondary windings, transformer with one primary winding, two secondary windings, and a mobile core. Two secondary windings, S1 and S2, one primary winding and a mobile core. It's actually a transformer. It has a single primary winding and with external source of AC voltage connected to the external AC voltage. Primary winding AC voltage is connected to secondary windings connected in series opposition. It is a variable because the core is free to move between the windings. It is a differential because of the way the two secondary winding. It is called as differential because two secondary windings are connected being opposite to each other, series opposition, 180 degree out of phase. Mean the output, this device will be, the output of the Lvdt will be the difference between the voltage output of the two secondary windings. Two secondary windings are connected in series opposition, having the same equal number of turns but connected in series opposition. An AC voltage with a primary with a frequency between 50 to 250 Hz is applied to the primary winding. Two voltages Vs1 and Vs2 are obtained in the two secondary windings S1 and S2. The output voltage is the difference between the two voltages Vs1 and Vs2 are combined in series because this minus because they are connected in 180 degree out of phase the voltages, so therefore Vs1 output voltage resultant output voltage is the difference of the two secondary winding voltages Vs1 and Vs2. The AC voltage output from a Lvdt indicates the position of the mobile core. 0 volts means the core is at the center. Further away the core is from the center position, greater percentage of input excitation voltage will be seen at the output. The phase output voltage relative to the excitation voltage indicates which direction from the center the core is moving. Here the two secondary windings having equal number of turns and connected in series opposition, so the output voltage is the difference of the two secondary winding voltages Vs1 and Vs2. So the core position is at the center, that is called as null position, central position. So initially the core is at the center position, the soft iron core will remain in the exact center of the farmer.
Therefore the linking magnetic, it is going to linking the magnetic flux produced in the two secondary windings will be equal, because having equal number of turns and the core is at the center, so equal flux linking from the primary to the two secondary windings. So therefore the induced EMFs in the two secondary windings S1 and S2 will be the same. Therefore the output voltage is the difference of the two secondary winding voltage will become 0. Therefore the net result at the output remains will be 0 volts. The voltage induced because of them will also be equal. Therefore the resulting voltage S1 and S2 will be 0. It is called linear because the core. Now when the core is at the center, the output voltage will be 0. Equal EMF will be induced in the two secondary winding from the primary to the secondary. The flux linkage will be same. So it is going to induce the same voltage at the secondary winding S1 and S2. Therefore the two secondary voltages will be same and having opposite phase. So the resultant output voltage of the secondary winding voltage is the difference of the two secondary winding voltages Vs1 and Vs2, and having opposite, they cancel each other, and the resultant output voltage will be 0 when the core is at the center. When the core is at the center. When the core is moved to left side up towards left side, in this position the linking flux at the winding when the core is move towards left side, more flux links with the in the winding S1, as a value more than the linking flux at the winding S2. Therefore Vs1 is greater than Vs2, and hence the output voltage is Es1 minus Es2. The output voltage equation is, when the core is moving towards left, the output voltage equation, which is Vs2 minus Vs1, actually the output voltage equation is Vs2 minus Vs1. Therefore, when the core is moving towards left, more flux links with the coil S1 than S2. Therefore, ES1 is magnitude is more than the ES2, but the output voltage V0 is ES2 minus ES1. So the magnitude of ES1 is more than that of ES2. Therefore, it is negative. So when the core is moving towards left, the output voltage is negative. similarly, when the core is moved towards the right, the more flux links with the coil S2 than S1. Therefore, the induced voltage at the secondary winding S2 is more than the winding S1, ES1. So ES2 is more than ES1. So therefore, the output voltage V0, which is the difference of ES2 minus ES1, will become positive, and therefore the phase angle and the resultant output voltage in phase with the voltage of ES2. From these three cases, when the core is at the center, when the core is moving towards left, when the core moving towards right, the difference voltage Vs2 minus Vs1 will depend upon the right left of the core from the null position. Also, resulting the voltage is in phase with the primary winding voltage for the change of the arm in one direction, and is 180 out of phase for the change of the arm position in the other direction. Secondary voltages Vs1 and Vs2. Related to the primary coil, the primary coil voltage is Vs sin theta. Secondary induced voltage V0 is secondary coil induced EMF V1 K1 sin omega t, V2 is K2 times sin omega t, where K1 and K2 depend on amount of the coupling between the primary and the secondary coils. K1 K2 depend on amount of coupling between the primary and secondary coils, which is proportional to the position of the coil. The linear variable differential transform when the coil is in the central position.
K1 is equal to K2, V out is equal to V1 minus V2, V2 minus V1 we can write. When the coil is displayed by X units, V out is equal to K1 minus K2 into sine theta. The positive or negative displacements are determined from the phase of output voltage V out that determines the positive or negative displacement, positive side or negative side, left side, right side displacements determined by the positive and negative phase of the output voltage. When it is positive, the core is moving towards the right. When it is negative, the core is moving towards left, like that. You can see some primary to secondary windings. These are wound and a hollow cylindrical farmer. Hollow cylindrical farmer. This is a hollow. This is the hollow cylindrical farmer. This is the hollow cylindrical farmer. Two coils are mounted. Secondary windings have equal number of turns. They are placed on either side of the primary winding. The primary winding is energized from the AC source. It is connected to the AC source. When output core is in central position, the induced EMFs when the core is in the central position, the induced EMFs in the secondary windings are equal and opposite in polarity. When the core is at the center position, the induced EMFs in the secondary windings, two secondary windings S1 and S2 are equal and opposite each polarity. So therefore the output voltage, which is the difference of the two, will be 0. The core is at the center position. The induced EMFs in the secondary windings are equal and opposite polarity. So therefore the output voltage is 0. An external force moves the core in either direction. An external force moves the core in either direction. Therefore, a difference in induced EMFs in the secondary winding will occur. Difference in the induced EMFs in the secondary windings will occur. This is due to the differential flux linkage by secondary windings. The difference in induced EMFs in the secondary windings will exist when the external force moves the core in either direction from the center. So therefore a difference in the induced EMFs in the secondary windings will come, which is not equal. Because the core is moving towards our left or right, there is a difference in the voltage in linking, flux linking with the two secondary windings will be different. So therefore there exists a differential flux linkage by secondary winding. The output voltage is function of the core position. When the core towards left, more flux links with the coil S1 than S2. So therefore more EMF will be induced in the second winding S1 than the S2. So therefore
the output voltage, which is the result difference of the two, that is the Vs2 minus Vs1. Since when the core is moving towards left, more flux links with the coil S1, so S1 magnitude is more, therefore output voltage will become negative. This indicates that negative polarity means minus sign indicates that core is moving towards left, center. Similarly, when the core moving towards right, more flux links with the coil S2 than S1, so therefore induced EMF in the secondary winding S2 will be more than the induced EMF in the primary winding, secondary winding S1. So the output voltage, which is the difference of the two windings S2 minus S1, will be positive, and the magnitude is proportional to the moment, and the polarity will give the direction of the movement of the core. When the polarity is positive, the core is moving towards right. When the polarity of the output voltage is negative, then we can say the core is moving towards left. See this here, the output voltage magnitude. This is the output voltage waveform. V0 is Vs2 minus Vs1. This is 3, this is 5, so minus 2, this is minus 2, so we can say the core is moving towards left. Here the magnitude of the output voltage proportional to the displacement of the core, and the polarity will decide the position of the core from the center, movement of the core from the center. Phase of coil 2, and this is phase of coil 1. This is phase of S2. This is the phase of S1. Observations: the output voltage is a linear function of the core displacement. relation between the difference output and displacement from each position of the core for a displacement of about 4 to 4 mm. High resolution, it produces high resolution of 10 power minus 3 mm. High resolution of the linear relation between the difference output voltage and linear displacement output voltage and linear displacement from null position for displacement up to 4 mm. So we can find that small changes in the movement of the core can also indicated with the output voltage. Sensitivity is very high. High resolution of 10 power minus 3 mm or still better. High sensitivity of 40 volts per mm or better. A small change of 1 mm will result in output voltage of 40 volts, which we can easily we can measure. So by knowing this voltage, we can easily find out the movement of the core from the center, at what distance the movement of the core is present from the center towards left or towards right, and at what distance from the center null. High sensitivity of 40 volts per mm. High, small, lightweight, easy to align and rugged. It is very small in lightweight, easy to alignment, is very easy and rugged in construction. Low hysteresis and hence easy repeatability. High output voltage, low losses and low power consumption, less friction. So it produces resolution of more than 10 millimeters, produces high sensitivity, more than 40 volts per 1 millimeter, small in size, weightless, its weight is very less, rugged in design, produces low hysteresis and thus easy repeatability, low power consumption. It consumes very low power for its operation, and very good linearity between the displacement and the output voltage. These are the advantages of a linear variable differential transformer. Disadvantages: here the total circuit is to be shielded, as the accuracy can be affected by external magnetic field. So the measurement depends on the external magnetic field. The whole total circuit is shielded, as the accuracy can be affected by the external magnetic field. Some magnetic circuits come close to this Lvdt, the readings may get flux links with the other magnetic field, that results in the error output voltage. The displacement may produce vibrations which may affect the performance of the device. The displacement may produce vibrations which may affect the performance of the device. Vibrations may lead the device to damage. produce the output with less power produces the output with less power, local consumption. Efficiency of the device is easily affected by temperature. It is affected by the temperature involved when the DC output. Sensitive to stray magnetic field, hence the shielding is required compulsory. It is sensitive to the stray magnetic fields. Magnetic fields when come close, the resultant output voltage not depends on the movement of the core but also the induced EMF of the other external magnetic fields. Performance occasionally affected by vibrations. The performance occasionally affected by vibrations. Output unit is required to operate an AC signal. For DC output, the demodulator is needed. Low power output voltage having low power, performance is temperature sensitive. The voltage what we are getting at the output of the secondary winding depends on the temperature also. Coming to the applications, Lvdt is used to measure the displacement ranging fraction millimeter per centimeter. Very small minute changes, movements can be measured using the Lvdt. Acting as secondary transducer, applications. Lvdt is used to measure the displacement ranging from fraction of millimeters to the centimeter. Small changes, movements can also be determined using this Lvdt. Acting as a secondary transducer, Lvdt can be used as a device to measure the force, weight and pressure. So first, to measure the force, weight, pressure, first we need to find that the force into displacement. So the displacement is measured first, then we can find out with the displacement the pressure. Measuring in jet engine controls in a close proximity to the exhaust gases. Jet engine controls, which is very close exhaust gases which are at high temperature. The movement of the jet engine gas thrusts we cannot identify, so that we can measure using Lvdt. Measurement of material thickness in hot strip or slab steel mills. Also used the Lvdt as an accelerometer. The measurement of roll position, we can use the Lvdt. For the measurement of low frequency vibrations, we are going to use Lvdt. Low frequency vibrations we can measure using Lvdt. For the measurement of long duration shock motions also we can use Lvdt. This class we have learned the construction working principle of a linear variable differential transformer, its advantages, disadvantages and the applications of Lvdt. So coming to the small quiz questions.
Displacement transducer. Answer. Lvdt converts dash into dash. Lvdt converts dash linear motion into electrical signal. Electrical signal into linear motion. Electrical signal into optical signal. Optical signal into electrical signal. Lvdt converts linear motion into electrical signal. Lvdt converts linear motion into electrical signal. The answer Lvdt has cells usually two secondary connected in series addition, series opposition. Two secondaries connected in series addition. Two in Lvdt, two secondaries are connected in series opposition, series addition, parallel opposition, series opposition. Because the windings are one out of voltage out of phase with each other, so it is only series opposition. One of the following transducer is used for the very small linear displacement measurement. One of the following transducers is used for the measurement of small displacements. Lvdt, strain gauge, thermocouple, capacitive transducer. For small measurements, what are the transducers used are for the measurement of small movements? Lvdt, strain gauge, thermocouple, capacitive is used for the measurement of small movements. Questions fixed frequently coming on this topic in the examination or explain the working principle of Lvdt. Explain the working principle of Lvdt.
With the help of a neat figure, explain the construction and working of Lvdt. With the help of neat figure, explain the construction and working of Lvdt. List the advantages and disadvantages of Lvdt. List the advantages and disadvantages of Lvdt. Give any 4 applications of Lvdt. Give any 4 applications of Lvdt. Coming to one more applications of mention any 6 applications of mention the 6 important applications of strain gauge, potentiometric transducer, capacitive transducer and inductive transducer. Mention the 6 important applications of strain gauge. Applications of strain gauge for the measurement of strain and stress in experimental stress analysis, to investigate strain in many structural materials for a wide range of environmental conditions, for the measurement of temperature, for the measurement of pressure, for the measurement of acceleration in medical field investigation. Applications of potentiometric transducer. 6 applications of potentiometric transducer are: resistive transducers have many and varied applications for the measurement of displacement. We are using potentiometric transducer in the measurement of displacements and the mechanical strain. We can measure pressure, we can measure force and load, can measure the temperature and fluid velocity in electrical outputs and control applications. Potentiometric is transducer used in control applications of capacitive transducer. 6 applications. Capacitive transducers are used for the measurement of both linear and angular displacement. They can be used for the measurement of force. They can be used for the measurement of pressure. They can also be used directly as pressure transducer. These are used for the measurement of humidity in gases. Capacitive transducers are commonly used in conjunction with mechanical modifiers for measurement of volume, density, liquid level, weight. Inductive 6 important applications of inductive transducer. Inductive transducers are used for the measurement of physical quantities such as displacement, force, pressure, velocity, position and vibration. So in this class we have studied the construction its advantages, disadvantages and applications of Lvdt, and also 6 important applications of different strain gauge, potentiometric transducer, capacitive transducers and inductive transducer. 6 applications.